Well, hi guys, it's Cliff here from Down Under. I've been having a lot of fun lately getting some parts together for ThreadExpress and machining up a short run of spindles. Took me a while to decide to do that, but I finally got underway when I just realized there was about 4 good reasons to do it. And the first one was it's an opportunity for me to do some advanced lathe work and demonstrate some lathe turning techniques in this series of videos. Also, I thought for folk wanting to build their own ThreadExpress, then there would be an opportunity for me to make some guidance videos to show you how to make the different key components. Third reason was that I would actually produce some parts that may be wanted. And the fourth and not last reason is that I just thought it would be a whole heap of fun machining up some parts and getting a bit more deeply into this invention. So in this first video, I'll just talk about getting started and considering the different options, the beginning of the journey, video number 1. Please watch it through to the end and let me know your thoughts on the idea of making components and instructional videos for those building ThreadExpress, so when they make their own they can get some tips and tricks as to how to make each individual part, or at least the more complicated parts. Before I get down to this video about lathe turning tips and tricks, are you familiar with ThreadExpress? Have a look at the recent videos that introduce the little attachment more completely. It is an indexing and thread milling attachment. I'll run a few seconds of video now just to remind us what this machine can do, and then we'll get on with the main video, which is going to be lathe turning tips and tricks, and also for people wanting to build the components for ThreadExpress with some instructional information on how you can efficiently make the components. I've been buying in some components to help Presso with his build, and also to help finalize the specifications for the drawings and plans and so on. And it's helpful to have actual parts and not just theoretical dimensions. We've got some more parts coming in, and this is getting me all enthusiastic about it. I'm feeling a lot more enthusiastic about the project now. I'm sort of classifying it as a hobby labour of love rather than some sort of a business project. I think as a business it's highly questionable, but as a hobby labour of love it's easy to justify, and I can just spend time on it in my spare time. I'm still running a couple of businesses, producing hallmark design products, probes and so on, and also doing contract tool making and precision engineering for a local New Zealand industry. But you know, I get a bit of time during the week and evenings and weekends where I can work on my hobbies, and so I've been getting these parts in. I'm thinking, well, why don't I make up some spindles while I'm at it? That'd be quite fun. And then maybe I'll have a few parts on the shelf to help some builders in the future. They may want to get a kickstart, they're prepared to pay a bit so they can get their little build of their ThreadExpress off the ground a bit quicker. It's always hard trying to decide how big a number of parts to make. It's a fascinating subject for me, production quantities. I've had a background in manufacturing for many years, and I can see all of the pros and cons. You know, if you're a hobbyist or a one-man band, small business, and you're building a ThreadExpress and you want to cut one spindle, and you've got to source the material and work it all out, each stage of the machining operation. You probably spend quite a lot of time just making one, you know, maybe 20 or more hours to machine one up with all the various threads and diameters and things. But if you made, say, 5, that would be a small lot batch production, which is what I'm considering doing here. I'm just sort of toying with the idea. If I made 5 of them, the number of hours per part would be much less. But that is nothing like mass production. You know, a big production CNC shop, you know, especially if it's in China where the governments and councils subsidize their raw material, subsidize their rent, subsidize the lease of their CNC machines, and the wages are very much lower. They could produce a run of, say, I don't know, 200 spindles and get the price right down to a fraction of what we can make them for in the West. Even with the markups and the freight getting into the US, the price would still be a fraction. But you know, if it's a hobby, it's all about the fun of making it and the joy of making it, and the independence of being able to make things yourself. That is important as well. Don't get me wrong, I'm not considering full-scale commercial parts production. A machine of this size has just got too many components and for a one-man band to consider something like that. You need to be a decent-sized company to get into the manufacture of parts for something like this sort of accessory. I'm just making a few parts as a hobby project, and I might build 1 or 2 machines over a period of time, and there may be some enthusiasts around the world that would want to pick up something, but I have no plans to run a commercial venture. The choice of what materials to use for the different components is always fascinating for me. For example, the key part, the spindle, I'm using medium tensile steel for these parts. If they were produced in volume to a high quality standard, they would ideally be hardened and ground, you know, case hardened, induction or through hardened, and then ground. But that doesn't suit low volume production. There's all sorts of difficulties with that type of production that require specialty equipment and quite high establishment costs. You get problems with distortion, you need special gear for thread grinding and so on. So we're left with high tensile or medium tensile steel, and that's not a bad choice in this application because the spindles are running in bearings, taper roller or angular contact bearings, and as long as the thread's to a good finish, for example a lapped finish, it's running with a bronze nut, so it should be fine running in grease. I think it's really worthwhile to get your machining sequence carefully settled in advance before you even begin, and it's quite difficult to make yourself do this. It sort of goes against human nature. Human nature just wants to take life a step at a time, but if you take it a step at a time, you run a real risk of painting yourself into a corner. There's all different ways that you could machine the spindles, for example. You've got to take into account how many you're making. I'm making about 5, so I think this is the best procedure for me. As far as I can see, I'm not painting myself into a corner with this sequence. So I'd first of all drill the core holes with a pilot drill and then an 18mm drill and put a center in one end, and that's because I don't want to do it at the end and risk releasing any possible stress in the core of the spindles and causing the spindles to bow or distort. After I've done that, I can chuck the chuck end of the spindle, put a center in that center, and then rough machine all of the spindles with about 0.3 or 12 thou left on the diameters for cylindrical grinding. Turn the thread to 32mm. Then the next stage, I think, is to clean my lathe lead screw, because I want to do some precision screw cutting. I don't want any little bits of chips in the half nuts or on the lead screw. Then make a lap and some nut gauges. Then set up the lead screws and then set up the spindles and screw cut all the threads and use the gauge that I've made back here to get the right fit. And I can lap them with my lap to fit the gauge. Then finally turning them round, holding them in a chuck. Got to be pretty careful how I clock that up, because otherwise I'll get a run out, and then machine the chuck end for the ER32 thread and taper and so on. Then the very final operation is to put it between centres in my Brown and Sharp and cylindrically grind between centres. Now I don't think there's any places there that will get painted into a corner, but you know, there's always a risk. It's pretty hard to visualize a job right through, but it's certainly worth the effort. It's much more likely to go smoothly if you do that. When I say paint yourself into a corner, I mean in two different ways. You don't want a sequence that causes you to get stuck at a certain point because you hadn't thought it through, but also you don't want a machining sequence that is inefficient and takes a lot longer. There's nothing worse than finishing it and realizing it if you'd only did it in a different order, it would have gone a lot more quickly and smoothly, especially when you're making multiple parts. That's really frustrating. So here I've just faced the end. I'm going to put in a center drill. I'm going to drill through with a pilot drill that'll punch through more quickly than the big drill, which is going to size it out to 18 millimeters right through. Well, I've decided to go for an even smaller diameter pilot drill. I ground the web down as much as I dare, because it's that very center portion that slows the whole process down, because you're moving metal that's turning very slowly. In fact, it's not turning at all in the middle, and so a very sharp thinned web really speeds things up. Well, I've got to drill through for 5 of these about 1 1/4 meters of steel, so I need an efficient process. Let's try this setting. Yep, that's pretty fast. Winding the tailstock handle pretty quickly, so I'll stick with that. I think it helps to use cutting oil to lubricate the cutting action and keep it cool, but you get a lot of overspray, so I made up this ugly contraption to catch the cutting oil overspray, otherwise you lose a lot on the floor. Once I've drilled in a couple of inches, I can feel the swath, the chip starting to jam up inside the drill, and from that time on I back the drill out full length, which also doses it with the cutting oil and allows the cutting to go quite quickly. I'll show you the method I use. And that's it down to depth. We're now halfway. Well, that's the 12mm pilot holes drilled through the 5 parts now, and 5's a good number for me as a hobby. Gaining some of the efficiencies of back-to-back repetition, but I'm not having the drudgery of mass production. Now I've got the final size drill, 18mm drill, to put through all these parts. Let's have a look at how that goes. Drill seems to be doing the job quite well, holding up quite well. It's just high speed steel, and it's drilling quite straight. But it usually does when you're rotating the work. You've got to do something pretty seriously wrong for it to wander when you have a big stationary drill and a rotating work. Still enjoying machining metal after all these years. That's a worry, isn't it? Well, that's my 5 pieces machine now. I decided to turn the ends and add another stage in. Here's my sheet of stages. See, I always put them too close together. I'm such a minimalist. I need to space things out more because now I'm cramming them in. Another little stage here of turning the ends. That means I can chuck it on that end and it's effectively stopped by the 3 jaws, which gives it a nice Z position that won't creep. So you can sort of make refinements, but it's worth spending all the time you can to have an overview before you start. And the other thing I keep doing is not leaving enough space at the top of the sheet so that I can put it under the clip. I've been doing that for decades. Getting more and more materials in here. Got my bronze in for making the nuts, the ER32 collet nuts. And what else? Oh yes, some full form threading inserts. They're just cheap ones from China. I hope they'll be good enough. They're worth trying out anyway. So I was thinking that I could make a series of videos now with general turning tips and tricks. And also it could back up a double use as being a guide for people building their own ThreadExpress. They can follow these tips and tricks for some of the key parts they need to machine. So now we're going to machine the little bit of internal center at 30 degrees. It saves a lot of time if your 3-jaw chuck is both concentric radially and angularly concentric. Have you seen my video called Fix Your 3-jaw? A way that you can make it really accurate concentric, and you can hold your parts quickly and accurately. That's just for the stepped center to go into. It's a good idea if you have rotating centers that have a reduced diameter so that you can get in close with your turning tool. This one I made up there from a standard rotating center, and this is a type of rotating center that has insertable centers, and that's perfect for this because it's effectively like a step down center. You'll see it in operation in a minute. And another probe heading off tomorrow, DHL Express. This one's going to Florida. So you can see here what I mean by the step diameter sitting up against the end of the 3 jaws. That should give it a good Z position location. Although the cheap chucks got rather big chamfers on the end, I wish they wouldn't do that. You don't need such a big chamfer. With an accurate 3-jaw, it makes everything go more smoothly. You can just lightly nip it up in the 3-jaw there, push it into position with the tailstock center. That pushes everything in alignment, tighten up the 3-jaw, and then when you back off the tailstock, you can see how concentric it is. So the whole thing is running concentric without wobbles even before you start to machine it. That seems about right. I could probably speed it up a bit more, but really I don't want to have any accidents. I just want to take my time. You can see there the type of tool I'm using is the triangular type 6 edges trigon type of tool. They used to use it. It's an Iscar, really good brand. That's only a few cuts and I'll have that roughed out to size. I'm using the digital readout with the method where you have the end of the work as Z0, set it to diameter mode and have all your dimensions based off the end of the work. That way I can just machine to the digital readout and I have my dimensions up there to reference. So I'm cutting the 235 length down to 40.3, then I'll go down to the 32 diameter at 216 long from the end, and then finally the 25 diameter, 25.3 at 47 long. Well, I've sped it up to 510 RPM. You see I'm running coolant to stop the heat from building up. There doesn't seem to be any stresses in the steel to speak of. I've finished roughing it out now, and if I back the center out, it's all nice and concentric, and I guess that drilling the holes first would have reduced the stresses if there were any internal core stresses, or else it's just a nice piece of steel without too much stress in it. That's my tool there. They're the tips. Iscar WNMGs, we used to call them trigons. They're really good for roughing and even moderate finishing work in a light lathe, light machines like I have in this workshop. Well, that didn't take long at all, just 2 or 3 cuts on each diameter, but you know, it makes a heck of a mess. Look at it firing all over the workshop like bullets. I wish I could fit this in my Slant Pro CNC, which is all enclosed, but you know, that Slant Pro is just too short. It doesn't have room for a decent tailstock, and also if you're only making 5 parts, it's probably not that much quicker in a CNC by the time you get it all set up. This is definitely the way to go for 1 part. 5 parts, you could argue either way. Well, that's probably enough for this video. Thanks for following me through to the end. You can see I'm just toying with the idea of making a run of parts and a series of videos on turning and the lathe. Please let me know in the comments whether you would like me to continue with this. I'll base whether I carry on or not on the demand and interest I get from these videos. So the theory is I could make a run of parts, I could even build a few complete machines, or just see how it goes. I'll go off how you guys react. So please like and subscribe to the channel if you're not already, and please let me know your thoughts in the comments. Also, just checking that you're aware that Mark Pressling is currently building a ThreadExpress in his shop in Australia, and I'll put a link in the description below where you can jump across to his channel and see how he's going making up the parts.